The following diagram shows circle, center O, radius 4. Okay. Points A, B, C lie on the circle. The point D is outside the circle on OC. Angle ADC is 0.3. OEOC is 0.8. Find AD. Okay, so this is sine rule. We have sine 0.8 over x equals sine 0.3 over 4. So x is 9.71, or 80. B, find OD. Okay, so we can find this angle, which is going to be pi, because a triangle adds to pi, 180. So if we do pi minus 0.3 minus 0.8, that gives us 2.04. Now we can do cosine rule, because we have cosine 2.04 ... equals x squared, which is 9.70 ... squared, plus 4 squared minus 2 times I'm doing it wrong. Sorry, I used the wrong formula. So that plus that minus OD squared over minus 2 times 9.70 times 4. So I put it in the other cosine way, but you get that OD is 12.06, so 12.1. Okay, so now we need the area of the sector OABC. So we're going to have 1/2 r squared 0.8. Okay, so we have 6.4 centimeters squared, and the area of the region A, B, C, D. So we have to do the area of the triangle. 1/2. I'm just going to use the 9.70, the x, times the 12.0 ... sine of 0.3 for this whole triangle. So this side times this side times sine of that, and then we're going to subtract 6.4 because that's the area of that sector, and this ends up being 10.9. Alright, so for this one, we've got radius 12, 75 degrees center angle, tangents at A and B, meet at P, cosine rule, show the length of AB. So we've got AB squared equals 12 squared plus 12 squared minus 2 times 12 times 12 cosine 75. So this is 144 times 2, so 288. And this is also 288. And cosine 75 is going to be, it's not a special angle, so okay, that's why it's in the thing. So now we can take out a 288. 1 minus cosine 75, that's AB squared. So if we take the square root, and this is 144 times 2, so we can take out a 12, and then 1 minus cosine 75 stays in. All right, now B, find the length of BP. So this. So we have this angle, or sorry, that side length. So I think you can say this is a kite because you've got right angles here because of the tangents. And we know quadrilateral, so this thing adds to 360. So this has to be 105. And then I think AP and PB have to be equal because it's a kite. And then this bisects. So that, well, I guess that doesn't really matter so much. But we would have 180 minus 105. And then divide that by 2. And that's each of these angles here. And then we have this side length here. So we can use sine rule. So we'll have PB over sine. And when you do 180 minus 105 divide by 2, you get 37.5. And then we're going to have the thing, this AB, over sine 105. So when you do that, you get x is 9.21. Okay, so hence, find the area of triangle OBP. Okay, so we just have to find the area of these two triangles, like this one plus this one, and then divide it by 2. So we're going to have 1/2 AB sine 75 plus, that's the left triangle, 1/2 the 9.21 times the 9.21. So 9.2 squared times sine 105. Then we're going to divide that by 2. So you get 55.2 centimeters squared. And the triangle A, okay, so that's just this one. So, okay. That should be 40.9 for double I. All right, so for D, you want OAB sector. So you'd have 1/2 R squared, which is 12 squared, theta, which we actually don't know theta, so we can turn it into theta. So to turn it into radians, you multiply the degrees by pi over 180. Or you could treat it like it's part of the area of the circle and do 75 over 360 pi r squared. Either one will give you the right answer. So you should get 94.2 centimeters squared. And for E, we need the area. Okay, so that's going to be this whole, no, without dividing by 2. So this whole thing, because that was each of those triangles. And then we're going to subtract the area. Yeah, the area of the sector, which is that we just found. And you should get 16.2. All right, 32. The following diagram shows circle, center O, radius R, the angle AOB at the center. Chord divides the circle into minor and major. All right, show that the area of the minor segment is 1/2 R squared. Okay, so this is what we've been doing this whole time. So we're going to have 1/2. So the area of the sector is 1/2 R squared theta. Then from that, we're going to subtract the area of the triangle, which is 1/2 R squared sine theta. And we just factor out an R squared and theta minus sine theta. And in general, you can use that. So given that the ratio of the areas of the two segments is 2 to 3, show that. So we have 1/2 r squared theta and 1/2 r squared, nope. So that's the sector. 2 segments. Oh. Okay, so we have, that's the shaded segment up there. And the other segment is this whole thing, okay? So it's the area of the whole circle minus that segment. So it's pi r squared minus, 1/2 r squared. I'm going to use this one, theta minus sine theta. So the ratio of this, so small segment is 2 to 3. All right, so let me delete this. And I'll use the thing that we found. So 1/2 r squared theta minus sine theta. Okay, so if we multiply, 3/2 r squared theta minus sine theta equals 2 pi r squared minus 2 times that, which is just r squared, theta minus sine theta. The r squareds will go away. And we have 3 over 2. I'm just going to distribute it. Okay, so we have this. Now, if I add theta over, that's going to be 5 over 2 theta. This one. And if I want pi over there as well, so minus 2 pi. And then I'm going to add this over here to the 1 sine theta. So that's going to be 2 over 2 plus 3. So 5 over 2 sine theta. So if I multiply by 2, I'm going to have 5 theta minus 4 pi equals 5 sine theta. And then they want to divide by 5. So theta minus 4 over 5 pi equals sine theta. So that is what they wanted, hence find the value, use and solve. So make sure you're in radians, I keep forgetting. So it's 2.82. All right, 33, we have the following diagram shows 2 semicircles. The larger one is center O, radius 4. Smaller one is center P, radius 3. Okay, so if this whole thing is 4, then PS is 1, okay? And that means this here is 2, okay. All right, so explain why OPQ is an isosceles triangle. Well, PO is equal to PQ, their radii. Okay, so now use cosine rule to show that OPQ is 1 over 9. Okay, so we have this is 3, and that down there is 3. We are looking for that. And we have O to Q is actually 4 because it's a radius of this other circle. So this is 4. So we're going to have that cosine OPQ is equal to 3 squared plus 3 squared minus 4 squared over 2 times 3 times 3. So we have 9 and 9, 18 minus 16, which is 2 over 18, which is 1 over 9. Okay, so then hence show that sine OPQ is that. Okay, so then that's going to be the relationship between sine and cosine is this cosine squared plus sine squared is 1, of course. So then we've got this is 1 over 9 squared. So if we do 1 minus 1 over 9 squared, that's going to be 80 over 81. And then we take the square root, and square root of 80 over 9. Find the area of the triangle OPQ. So we're going to have 1/2 AB sine of that angle, which is this. So it's root 80 over 2. Now BI, consider the smaller semicircle with center P. Write down the size of OPQ. Okay, we just have to do the sine inverse of this, or the cosine inverse of 1 over 9. So in radians, this is 1.45946. Now calculate the area of the sector OPQ. So we need 1/2 r squared theta, which is this. So 9 over 2 times that 1.45, which is 6.57. All right. Now consider the largest semicircle with center O. Calculate the area of the sector OQS. So we want that thing. All right. So this thing is an isosceles triangle. This. So we can find out this angle. So we can do pi minus that 1.45946. Divide that by 2, because this will be the same angle as this. All right, so pi minus 1.45, blah, blah, divide by 2. So we have that one angle is 0.841. So now to find this sector, we just have 1/2 4 squared theta. So we get 6.73. That's for C. Hence, calculate the area of the shaded region. So if you see what I drew up here, we have to, so we need to add the areas of these sectors and subtract this triangle, because basically we've added that twice. Okay, and then we're going to subtract that from the semicircle. So what we're going to have is pi r of this one is 3 squared, and divide by 2, because that's a semicircle. Now from that, we're going to subtract. So the area of the OPQ sector was in BII, which was 6.57. Okay, and we're going to add the area of the red sector, which was QOS in C, which was 6.73. And then we're going to subtract the area of the triangle OPQ, which was in 4. Of course, I did not label this, but I think it's root 80 over 2. So this should give us the right answer. and that gives 5.31.